Ignoring the power hack is missing allegations, today we are making a localization manager. This manager will be modular, meaning you can use it on any project. It will make use of Godot's translation server and CSVs for translation. It can also be extended to not only translate text but also assets, as we can see here. The image changes based on the set language or locale. Just a heads up, I may be using locale and languages interchangeably in this video. Like, subscribe, hit all the buttons, and let's get into it. Before we start building our system, we should be able to define it. Lucky for us, Godot has a built-in translation server that will do most of the heavy lifting. So the things we will need for our system are a central dictionary to store all translations for a selected language rather than loading every translation into memory at once, a way to communicate with Godot's built-in translation server so that it applies our translations, a way to track the active language and emit a signal whenever it changes. Alright, let's get into creating the localization manager script. First things first, we create a signal to announce when the locale or language has changed. When the signal is fired, it passes the name of the new language it's being changed to. Current locale is the variable for the active language. We will initially set it to English. The fallback locale is self-explanatory, it's a safety net. If current locale is changed to a new language whose translation does not exist, the system will just use English instead. Next, we define a directory path where all the language files are stored, and we set up a dictionary to hold our loaded translations. In the ready function, we first load the fallback language into the translation server for safety. Then we load the saved locale as the current locale and apply it, as it should be fully loaded by now. We then create a private function to apply our chosen locale. First, it checks if our current locale exists. If it doesn't, we push a warning and set the language to our fallback. The function then loops through any previously loaded translations and removes them from the translation server so that no old data is left over when switching to a new language. It also clears the dictionary that holds the loaded translations. Next, we check if the applied locale is different from the fallback locale. If it is different, we create and add the translations from the fallback locale into the translation server. This ensures that even if the applied language isn't the same as the fallback, our fallback is still loaded into the newly created translation server. If the applied language is the same as the fallback, this step is skipped so that the locale is only loaded once in the next code block. Here, we simply parse, add, and set the applied locale to the translation server. If the applied locale is the fallback locale, only one translation will be loaded into the translation server. However, if the applied locale is different from the fallback, we will end up with two translations added to the translation server. Next, we write a private helper function to parse and create our translation. Its job is to create our language folder and convert all the raw data into something Godot can understand. It starts by creating a new translation object called tr and sets its local properties to match the language you are trying to load. A variable named directory path builds a full path string to the specific language folder using the base path constant. For example, in our setup, it would look for the English language files inside an English folder located within the language folder. If the script fails to open the folder or cannot find the directory, it pushes a warning to the debugger and returns without doing anything, preventing errors. If the directory is found, it loops through every file inside it using directory getNext. It then checks whether a file ends with .csv and does not start with a dot. Once it finds a valid CSV file, it calls the parseCSV helper function to help read it and merge it with any other CSVs found in the directory. Finally, it returns the compiled translation data. Looking at the parseCSV private helper function, its job is to take a file path, read its content, and convert the raw text data into a specific dictionary that can be used for translations. It starts by attempting to open the path for reading. If it fails, the function returns early without doing anything. If it successfully reads the path, it skips the first line of the CSV. The function then loops through every remaining line in the file until it reaches the end. It reads each line and removes any leading or trailing white space to ensure clean data. Next, it checks if the current line in the CSV is empty or begins with a hash. This prevents the script from crashing if you have blank lines or comments, making your CSV files much more readable. This line tells the engine to separate the string at the first comma only. This ensures the key and text in the CSV are neatly separated into key value pairs without further dividing your text value if the translated text itself contains a comma. Finally, it checks if the split resulted in exactly two parts. If it did, it uses the first part as the translation key and the second part as its value. These next two private functions manage language persistence. The save locale function saves a locale as a configuration file, while load locale loads that configuration file if it is found. I also added a reload function as a quick way to refresh the localization if needed. The set locale function is responsible for language switching. First, it checks if the newly set locale is the same as the current locale. If it is, the function just returns. If it isn't, it updates the current locale to the new locale, applies it to the game, saves it as a configuration file, and emits a signal announcing that the language has been changed. Basically, this script acts as the bridge between the game and Godot's built-in translation server. In our sample scene, we add a script to our option button node. This will use methods from the Locale Manager, so I won't go over what every single line does, but feel free to pause and read through it. But before we forget, let's set our manager as an auto-load. On that note, to actually use the Localization Manager, we first need to create our language files. We will use the CSV format for this. Personally, I prefer having individual folders for language files rather than one large file. You can modify the Localization Manager to use whatever structure you like. For this demo, I will create translations for English, Spanish, and Chinese. In the CSV, we will have two columns, one for the key and one for the value or text. We will use the key as a placeholder on our UI, then at runtime, the engine will replace all the keys with appropriate text based on the selected language. I'll jump ahead to when I'm done writing the CSV. Now that we have everything set up, we can put the following code in the ready function of our options button script. Next, we add a sync selection function. Finally, we add an on-language selected function to handle the signal fired when picking an item from the option button drop-down menu. Now for a quick extra tip, I'll quickly go over localizing assets. It's quite easy, you just need to reference the appropriate file from your language file. For example, you can set a key for an image asset and have the text point to different image files based on the translation. That's what I used to achieve the image changes you see here. I've added some lines to the option button and language files to help illustrate this. With all that said, don't forget to like, share, and subscribe. I'll be reading the comments, so please say hi. If you would like to support the channel, I have a Buy Me a Coffee page. Thanks for watching, and I will see you when next I leave my cave.